Alright, we want to graph y equals the absolute value of x. Now, anytime you're graphing something you don't know how to graph, or something you haven't graphed, you don't know any specific way of graphing, you can just pick x values and put them in. So let's put in -2, -1, 0, 1, and 2. And we'll find the y values that go with it. So if we replace x with -2, the absolute value of -2 is +2. So we have a point at -2, 2. Now let's put in -1. We have y equals the absolute value of -1. Absolute value of -1 is +1. So we have a point at -1, 1. Now let's put in 0. Absolute value of 0 is 0. So we have a point at the origin. Now if we put in 1, y equals absolute value of 1, that's 1. So we have a point at 1, 1. And then if we put in 2, absolute value of 2, that's +2. And so we get a point at 2, 2. Now we'll connect these, and we'll put arrows on the end. It continues in that pattern. Absolute value always gives you a v. Now it may open up or it may open down, but absolute value functions always give you a v. The point where it's the minimum or the maximum is called the vertex. So our vertex here is 0, 0. That's our vertex. It's either the minimum point or the maximum point on these absolute value graphs. Now, vertex form for an absolute value graph is y equals a times, and then inside of the absolute value, x minus h, and then plus k. So your h and k is your vertex. For this particular graph, we should be able to look at it and tell that the h is 0 and the k is -1. So we have a vertex at 0, -1. Now what we want to do is put in x values on each side of that. So to the left of 0 we can put in -1, we can also put in -2. And then to the right of 0 we can put in 1 and then +2. So let's put those values in and see what comes out. So once you've located your vertex, that's really all we need vertex form for. I'm going to erase that now. Replace the x with -2, and let's see what comes out. We have y equals absolute value, -2, and then -1 outside of the absolute. Absolute value -2 is 2, and then 2 minus 1 is 1. So we have a point at -2, 1. We can put in the -1. Absolute value of -1 is 1. 1 minus 1 gives us 0. So when we put in -1, we get 0 out. Now if we put in 1, absolute value of 1 is 1. 1 minus 1 is 0. And then if we put in 2, we put in 2, y equals absolute value of 2 and then -1. Absolute value of 2 is 2. 2 minus 1 gives us 1. We'll plot those points. We got 1, 0, and we also have 2, 1. Connect those and you'll have your absolute value graph. Notice that these absolute value graphs are symmetrical. with point -1 and positive, -1, 0, and 1, 0. Those are symmetric across the axis of symmetry. If we drew a vertical line through the vertex, we'd have an axis of symmetry. It splits it in half. Okay, here, if we think about that HK vertex form, y equals a times x minus h plus k. Your h here is -2, and your k is 0. So that's our vertex. We'll put some x values to the left of -2, like -3 and -4. And then we'll go to the right of -2, -1, and 0. So again, the h, notice where it is. It's inside of parentheses, and it's the opposite of what we'd expect. And then the k is what we see out there, or what we'd expect. Now let's substitute these values in. So replace x with -4. We have y equals. This time you're adding 2, and then you'll take the absolute value. -4 plus 2 is -2. Absolute value of -2 gives us +2. So we have a point at -4, 2. Putting in -3, y equals absolute value of -3 plus 2. Add 2 and then take the absolute value. -3 plus 2 is -1. Absolute value -1 is +1. So we have a point at -3, 1. Substitute in -1. Absolute value -1 plus 2 is 1. Absolute value of that is 1. So we have a point at -1, 1, and then let's put in 0. So absolute value of 0 plus 2. 0 plus 2 is 2. And absolute value of 2 is 2. So we have a point at 0, 2. Now we'll connect those. We'll have our graph, put arrows on the end, just showing that it continues on forever in those directions.